Catchphrase! I don't have a good YouTube catchphrase yet. I'm still working on that. Let's talk about ifs and conditionals, sometimes known as branching, for Intro Computer Science. So a quick note, some of these examples use a scanner. You may not, depending on how the curriculum is set up for a particular term, have seen the scanner video yet. It's pretty short. Go ahead and watch it here. And just in case you don't get through that or watched it a while ago and need a refresher, here's the general idea. You create a new scanner. Scanner's a reference type. You can name it anything you want, but I usually name it SC or scan. You assign it the result of this constructor, new scanner, and then the parameter is system.in. You can think of system.in as the opposite of system.out. System.out is what you use to do print or print line. System.in reads input, but it doesn't do it on its own, so what you want to do is pass it as a parameter into a scanner. The scanner has a much nicer interface or API for reading things. Here's what that looks like. So you take your scanner, you say next int. That means sit here and wait until somebody types in a number, and then when they type in that number and then hit enter, stick it into this variable x. And then down here, if you read a string, that'll go into s. Now I should note, strings can't have spaces in them. If you put a space in it, then that means it's the next string coming after that space. So next does not include spaces. I was going to do a quick demo in BlueJ. I'm actually going to skip that. If you're really interested, go watch the scanner video. So learning goals, if then else, boolean and or not, also primitive and reference types. Now this stuff is kind of like not covered in the reading. I want to throw this stuff in here now because it's pretty important, especially primitive versus reference types. People need to see it a few times usually for a lot of the implications to really start sinking in. And some of this stuff, chained ifs and nested ifs, I think I'm going to punt to the in-class clicker questions. So moving on. If then and if then else in Java. So if some condition is true, open a bracket, do one or more statements, close a bracket. And so condition, this is a boolean. So that means it has to be something that evaluates for true or false. It can be a literal boolean variable, boolean's a new primitive type, or it could be something like x greater than y, or x less than 10 and y greater than 50, or something along those lines. Now the body's one or more statements, and remember, a for loop is a statement. An if then, or an if then else, those are both statements. So body is meta. It can have ifs inside it, it can have loops that have ifs inside it, and so on and so forth. So let's look back at Scratch for a moment. So we've got when the start flag is clicked, set a variable to a random number between -10 and 10. Now, if that number is greater than 0, then do everything that's in here. Well, there's only one thing in here, which is say positive number. Now there's a say done, but that's after this if is already over. See, this is a separate block than this if. This is the only block that's inside what's called the body of that if. Well, this is what this would look like in Java. Now, it's not exactly what it would look like in Java. Up here in Scratch, we're actually picking a random number for -10 to 10. Here in Java, we're just going to use the scanner to read in an integer from the user. The reason I'm not using random in Java, there is a way to use random. We'll learn it later in the term. It seemed easier just to go ahead and use the scanner. And then you can see if, here's that parentheses, and inside this is a condition. If the variable number is greater than 0, then print positive number. And then we have this print done. That's the same as the say done down here. So these have a correspond to each other. Now let's look at an if then else. Basically the same thing. When you click this start flag, set this number variable to between -10 and 10. And if it's greater than 0, print positive number. Else, it must be a negative number or 0. And exactly one of these says will happen. Never both, never neither. Exactly one. So to translate this to Java, again, more or less to Java because we're using random up here, and then down here we're just using a scanner. But in either way, it's a way to get some kind of arbitrary value into num. If num's greater than 0, print positive number. Else, print negative or 0. So that's an if then else. Now sometimes you might want to combine booleans together. So you actually want to check multiple conditions. So if you said blue or you said red, then I'm going to jump up and down. Or if you ate pizza and you ate ice cream on Thursday, then it was a really good day for eating. So suppose we have two conditions, A and B. Now what A and B are, totally left abstract. A might be x greater than 5. B might be y less than 100, something like that. To combine these together with OR, which is a double vertical bar, that is shift backslash, usually right above the enter key, A or B, well, in order for that to be true, either B needs to be true, or A needs to be true, or both need to be true. The only way for this to be false is for both A and B to be false. Now, and A and B, and is ampersand, which is shift 7. A and B, well, the only way to make that true is for both A to be true and for B to be true. As soon as one of them is false, or both of them are false, the whole thing is false. The result of this combined and is going to be false. And then, of course, there's not A. Well, if A is false, not A is true. And if A is true, not A is false. So not is not super difficult to understand kind of what's going on. Now, why are we using double vertical bars and double ampersands rather than, for example, the word or and the word and? Because we're using and or. Java's syntax derives from C and C+ syntax, which uses double vertical bar and double ampersand. Java dates from the early 90s, and it was very important at that point. C++ was the dominant language for a lot of big projects. It was very important that the transition be made as easy as possible for C++ programmers to adopt Java, so a lot of the C syntactic conventions were actually preserved in Java. Are these the best conventions for a programming language? Possibly not, and in fact a lot of modern languages, more recently invented languages like Python, actually use the words and, or, and not instead of these kinds of symbols. But it really just depends on the language, and after programming a language for a little while, these things just become automatic to the point where you'll sometimes see computer science people using double vertical bar, double ampersand as shorthands for and or when they're writing things. Couple of other notes about not. I should also note that the not symbol is just an exclamation mark. It's sometimes called a bang. You'll sometimes hear that. Bang equals down here. So like bang equals or not equal is the opposite of equal equal. This is just pronounced not equal. And something like not x greater than y, that means it's not the case that x is greater than y, which is really just another way of saying x is less than or equal to y. Because if it's not greater than, then it has to be less than or equal. So let's do an example. Go ahead over to Moodle, try this out. Int x is equal to scan.nextInt, int y, scan.nextInt, so we're reading in a couple of values. And then here's our if. These are possible values of x and y. This is input number 1, input number 2, and so on. Which of those inputs are true? I'll give you a chance to try that out on Moodle. Go ahead and pause me. I won't be offended. Did you come up with D? If so, you're correct. We just need one of these to be true. In other words, x has to be 0, or y has to be 1, or both. Well, if x and y are both 0, well then x is 0, so it'll print yay. If it's 0, 1, well then y is 1, it'll print yay. 1, 0 is the only one that doesn't work, right? 1 is not equal to 0, and 0 is not equal to 1. So number 3 is the only one that will not print yay. 4 will print yay because, again, y is equal to 1. Let's try another one. Let's make it, instead of an or, let's make it an and. Head on over to Moodle. Did you come up with B? If so, you're correct. For this one, they both have to be true. In other words, x has to be 0 and y has to be 1. Well, that's only the one case here, 0, 1. All these other cases, these aren't going to work. Now, sometimes you actually want to combine together conditions. So, for example, going back a slide, here we had x equal 0 and y equal 1. We're using equal. Suppose we want to combine less thans together. So you would have to write it like this: 10 less than x and x less than 20. This is equivalent to saying x is in between 10 and 20 exclusive. In other words, 10 and 20 aren't included. You cannot do this. You can't say 10 less than x less than 20. Why? Java's grammar doesn't allow it. Now, there are programming languages where you can do this. Unfortunately, Java is not one of them. This is annoying, and I have to explain this to students, and they're kind of like heartbroken every year. They're like, why do I have to do it this way, which makes no sense, instead of this way, which would make sense? All I can say is, I don't know, it was the early 90s. Things were just different back then. Not literally. There's probably some reason why it made the parsing or the grammar simpler. But anyway, you've got to check sort of both sides of the condition with an and in between them. You can't do this. This won't even compile. Operator precedence from highest to lowest, multiplication, division, mod. Actually higher than all those is the unary minus for negative numbers. Then plus and minus, then less than, greater than, less than equal, 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 and so on. Your comparison operators. Then not, then and, then or. Now, these are not the same priority, these logical operators down here. This matters. So if you write this, some Boolean condition, some condition, call it B1, B2, and B3. If you say B1 or B2 and B3, well, and has a higher precedence than or. So this is equivalent to writing it this way. I mean, we understand if you put parentheses here, it means you want to have this happen first. This is going to happen first anyway, right? So it's going to evaluate the result of this and then or the result with B1, even if you don't use the parentheses, because or has a higher precedence, and has a higher precedence than or. This is because in Boolean algebra, and is equivalent to multiplication, and or is equivalent to addition. So remember, and has a higher precedence than or. So there's two kinds of types. Now this is kind of background information leading up to how we would compare to see if two strings are equal or not equal. I know this seems like sort of a bizarre amount of background information to be giving, but it turns out to be really important, and it turns out to actually be kind of useful in the long term because we have to understand the differences between primitive and reference types. Turns out to be quite important. So the primitive types we've seen so far, int, double. There's actually a couple more we'll see later on. The reference types we've seen so far, string, simple grid, scanner. There's actually thousands more of them, and you're going to learn to write your own new reference types, and this is actually a staple of what's called object-oriented programming, is writing new reference types. So primitive types, they're called primitive types because they're simple. They're a fixed size. Ints are 32 bits, doubles are 64 bits. There's actually different versions of int, so byte, short. Byte is 8 bits, short is 16 bits. There's also long, which is a 64-bit int. But they're all a fixed size. So this means that integers, which mathematically are infinite, are not infinite in computing. 32 bits gives you about 4 billion different values, which are split about half positive, half negative. So from about negative 2 billion to about positive 2 billion. That's the range you have for integers. So they're a fixed size, which is really good because that means that when you need to create an int or a bunch of ints, you know exactly how big they're going to be. Strings, not so much. How big is a string? Well, I don't know. That depends. A string could be 0 characters, called the empty string, so the string with literally no characters, or a string could be as much memory as the computer has without making it crash. Just a bunch of words that are that big. The complete text of Shakespeare's plays, concatenated together 1,000,000 times or something like that. Reference types can also have methods. So simple grid and scanner, these have methods. Strings actually have methods too. Simple grid, you can set colors, you can get the width, get the height, stuff like that. Scanner, you can do next int, you can do next, things like that. You can't do that with primitive types. So I want to draw a distinction. I used to draw this on the board. What I'm going to do instead, I turned it into some slides. Now this is the first of many times you'll see this type of diagram, sometimes called a box and arrows diagram. It's useful because it explains why we compare primitive and reference types differently. And it actually has a lot to do with performance differences, which we'll see later on in computer science. Now for now, in your first class, you're going to look at this and be like, wow, Spacko, you're giving us a huge amount of detailed information that I don't really know what to do with. And that's true, I am. Some of it is just laying the foundation for some aha moments later on. For now, I apologize that I'm dumping some extra information on you that's not strictly necessary, but it does help to explain some things. So here we go. We've got some Java code. So we've got int x and int y. We're assigning those 1,000,000. Integers are a fixed size, so that's fine, x and y. We've got our string s1. We're assigning it the string hello. Now remember, when Java sees it's got a string, it doesn't know how big that string is. And now it knows here it's 5 characters, but this string reference can actually refer to any possible string, which is, they could be huge. So what the reference part of it means, S1 is a reference. That means it's what's called a reference or a pointer. So what's in here is actually not the string itself, but almost like a forwarding address telling you, hey, over here in memory somewhere, there is this string that you should go find that's 5 characters long. So that's all that's actually going to be here, is this reference to where to go find the actual thing that we're looking for. That's why these are called reference types, and these arrows are actually references. We draw them as arrows, but literally they are an address of some other place within the machine's memory. But for our purposes, we'll just think of these as arrows. Now, in this case, x equal y is true, because x and y, these are both ints, and the two integers store exactly the same value. Equal compares what's in the boxes. Well, 1,000,000 is here, 1,000,000 is here, those are the same. Bam! These are equal. That's true. Well, let's add a second string s2. So here's the Java code. We're going to say string s2, we're going to assign it hello. Well, what's that going to look like in the memory behind the scenes, our conceptual understanding of how Java is going to represent this? Well, this is one possibility. Java might look at this and say, hey, S1 and S2, S1's hello, I've already got a string hello, I'll make S2 point to the same string. This is one possible way Java might implement this, and in fact, for a simple piece of code like this with only a few lines, it's almost certainly going to implement it this way. Now, what this means is that S1 equal S2 in this particular instance is true, because what's in S1? Well, it's an address. Sorry, what's in S1 is an address, what's in S2? Also an address, and those addresses are the same because they tell you to go find the same string. So in this situation, for S1 and S2, S1 equal S2, true. But Java might not do it this way. Java might not figure out that this is the same string, and there's many reasons why this might happen. I don't want to get into all the details here, but suffice it to say it's not super tricky to make it happen, and if you want, I can show you an example that'll make it happen basically every time. Just requires a little bit more stuff. So Java might not be able to look at this and figure out these are the same string for various reasons. So we may actually have two copies of the string hello. So S1 points to one of them, S2 points to the other one. Now if that's the case, S1 equal S2, false. The reason being, what's in S1 is an address of this hello, and what's in S2 is an address of this hello. These are different hellos, so these are different addresses. So S1 equal S2, false. Because equal just compares what's in the boxes. What's in the boxes are different addresses. So that's not going to work. Right? S1 equal S2 is going to be false. This is very confusing because if Java happens to implement it this way, going back 2 slides, S1 equal S2 would be true, but Java doesn't have to implement it this way. It may, for various reasons, end up being like this. So, what's the take-home message of all of this? Well, equal only reliably works with primitives. So you should only use equal with primitives unless you know exactly what you're doing. Because there are situations where equal with reference types is useful. So to compare two strings, or really any other reference type, you shouldn't use equal because it may not give you the results you're expecting. Instead, we actually use a method called dot equals. It's pronounced dot equals, but the dot part means it's a method call. So it's a method called equals. So remember, with ints, x equal y, that's fine. With the two strings s1 and s2, if we want to compare whether they are the same string, in other words, whether the word that these two strings reference is exactly the same, we take s1, we invoke this equals method, and we plug s2 in here. So I've given you some background. If you're not happy having to know all of that background about primitive and reference types, you can just memorize that with strings I have to do dot equals, and with primitives I can do equal. You're perfectly okay to just memorize that strings have to be compared differently, but I don't like to too often have to just say accept this on faith with no rationale. So I've at least given you the rationale, and we will return to this primitive and reference type distinction many times in CS in the intro, and certainly more as we get to more advanced courses. So moving on. So how do we check if two strings are equal to each other? Go over to Moodle and check this out. Did you come up with B, S1 dot equals S2? Gosh, I hope so, because we just went over an example of it. I personally would have answered E, S1 or not S1, a little play on Hamlet here. to be or not to be, S1 or not S1, that is the question. Whether 'tis noble to suffer the slings and arrows of compiler messages. Oh, compiler messages. So let's try this. How do we check if two strings are not equal to each other? Go ahead and try that out. Did you come up with D? If so, you're correct. The most common wrong answers for this are A and B. So a lot of people still want to use equal, equal, and not equal. But not equal, as you can imagine, is the complement of equal, equal. This actually just checks if these references are not the same reference. Well, that's not really what we want. What we want is to check if the dot equals is not true. B is just not the correct syntax. It happens to be that we have to do a D. So this just says, okay, take S1, use the dot equals with S2, which will be true or false, and then take the opposite of that. So D is actually the correct way to check if two strings are not equal to each other. And then finally, here's the next most common error pattern. Suppose we're checking to see if some string S is equal to elves or elves. So we want to check if the case is, we want to do a comparison, but we don't want to have to worry about case. So lowercase or uppercase, something like that. Which of these is going to be the one that we want? I'll give you a chance to try that out on Moodle. Did you come up with D? I hope you did, because D is correct. The most common answer, wrong answer that I've seen over the years would be something like A or possibly B, where you want to say, well, if it's equal to elves or elves. Well, the problem is or just says, well, it's this string or this string. Well, the problem is strings are not true or false. They're just strings. Now, is the string S equal to elves is true or false? Because either it's equal to elves or it's not. So you can say, is the string S equal to elves, or is the string S equal to elves with a capital E? This is correct because the thing to the left and to the right of this or, they both can be evaluated as true or false. This doesn't work because the thing to the left and to the right of the or are just strings, which are neither true nor false. They're strings. They don't have a true or false value. Same thing here, except here the parentheses and the quotes are all screwed up. And then same thing here. This is just, is S equal to literally this string. This is correct syntax, but it has the wrong meaning. So that's what is going on there. Fantastic. Thanks for listening, and let's continue learning more in future videos and clicker questions.